All right, so number 9 on 3.4 says find an nth-degree polynomial function with real coefficients satisfying the given conditions. If you're using your graphing utility, which we're not, and so we're not going to need to graph it to verify the real zeros of the given function value. But we will take what we know about polynomials and pick out which graph belongs with it. All right, so I see that n is 4, which means it's a 4th-degree polynomial, means it has 4 zeros, means my largest exponent at the end is going to be an x to the 4th. So go through here, but I noticed they only gave me 3 zeros. So again, the first thing I'm going to do is I'm going to find all of my zeros. So they told me that it was -1, 4, 2 plus 3i, but remember, since we have imaginary number right there, its conjugate is also, which means you change the sign in front of the I, so that means that 2 minus 3i is also a 0. So now we have 4 zeros. And again, I'm going to take and list out my factors. Well, the -1 gives me a factor of x plus 1. The 4 is going to give me a factor of x minus 4. Now, when you go to plug these in, both of these are positive 2. So one of the factors is going to be x minus, and then it's going to be the 2 plus 3i. And the 2 minus 3i is going to give me a factor of x. Again, that 2 is positive, so it's going to be minus. And then I just put the 2 minus 3i there. And then we can write it into factored form. So we got f of x equals a times my factors there. So x plus 1, x minus 4. And what I'm going to do is I'm going to go and distribute that minus through it. So this is x minus 2 minus 3i. And I'm going to distribute the minus here. So this one is x minus 2 plus 3i. Now, just like what we did in number 8, we're going to go ahead and multiply our factors together. You want to multiply those conjugates together. So I definitely want to multiply those last two together, which means I'm going to go ahead and multiply these two together as well. So when we do this, we get f of x equals a times, I'm just going to do FOIL on the first two there, so it gives me x squared minus 4x plus 1x minus 4. But now when I do these other, this is a 3 terms times 3 terms. And we can distribute. You could take this first x, I'm going to change colors here. You could take this x here and you could multiply it times all 3. And then take the -2 and do the same thing. And then take the -3 and do the same thing as well. But that's a lot of writing and gets a little confused. So what I found that students seem to like is the Punnett square. They use it in their science classroom, so they're already somewhat familiar with it. So I'm going to come over here for a minute, and I'm going to do the Punnett square to multiply those. So the Punnett square is just, it's 3 terms times 3 terms. So it's going to be a 3 by 3 square. So I got 3 rows and 3 columns here. And so I'm going to write down one of my terms on top. So I'm just going to pick the first one. And one of the terms going down the side. Or I guess just say the other term. Or, excuse me, factor, not term. Alright. And then we just multiplying. And so what we do is we're going to multiply for this first column here, this first box. We got first row, first column, so we're going to multiply x times x, and it's going to give us what we're going to put in there. So we got x squared. And then I'm going to go across, so now I'm going to take this -2 times the x, and that's going to give me my -2x. And then -3 times x will give me, -3i times x will give me -3ix. And then I move down to the next row. So now I'm in the second row, first column. So I'm going to take x times -2, and that's going to give me the -2x. And so I just keep going through here. So -2 times -2 is a positive 4. -2 times -3i is positive 6i. Now I'm on the third row, first column. So that's where I got the 3i times the x. That's going to give me a positive 3ix. I have 3i times a -2, so -6i. And 3i times -3i, which is -9i squared. But also remember, I squared is the same thing as -1. So this is like -9 times -1, which really comes down to give me a positive 9 that I'm going to use there. And then I just start combining those like terms. So I can see my largest exponent here is x squared, so I'm just going to write it down first. Not the color I was looking for, sorry. Let me change back to the other color because it'll help identify it a little bit, I think. So we got x squared. And then I have a negative 2x minus 2x, which is negative 4x. I have a positive 4 plus 9, which is positive 13. And then I have a negative 3ix and a positive 3ix there, and they cancel. And then 6i minus 6i also cancels. And I'll go ahead and circle my stuff so I can see that once I've got them all circled, then, excuse me, then I know I've used everything. So those conjugates there together gave me the x squared minus 4x plus 13. Alright, now we get the fun part of we get to multiply those two things together in that now. And so I'm going to go ahead now and erase that Punnett square. If you need to copy it down or whatever, go ahead. Pause it and do it. But I'm going to erase it because I'm going to go ahead, since this one's going to be, I didn't combine my like terms in that first parenthesis, which I'm going to first, but then it's going to be 3 terms times 3 terms. So I'm going to go ahead and use my my Punnett square again. So I'm going to erase it here. And I'm going to redraw it. But first, I'm going to go ahead and simplify this one more step here, because we do have like terms right there. So the first factor is x squared minus 3x minus 4, and the second one is x squared minus 4x plus 13. Alright, so I'm going to set up my Punnett square here. 3 rows, 3 columns. Okay, I put one of them going across the top. So I'm going to do x squared minus 3x, squared minus 3x minus 4 up here. I'm going to do my x squared minus 4x plus 13 on the side. And so again, I'm just going to multiply them. So x squared times x squared gives me x to the 4th. X squared times negative 3x is negative 3x cubed. X squared times negative 4 is negative 4x squared. And then the second row, negative 4x times x squared is negative 4x cubed. And negative 4x times negative 3x is plus 12x squared. And negative 4x times negative 4 is positive 16. And then finally the third row, 13 times x squared is 13x squared. 13 times 3x is negative 30, times negative 3x is negative 39x. And 13 times negative 4 is negative 52. Now the nice thing is if you have all of your variables in descending order, so like you got x squared is the largest, so you have it, and then you got an x and then a no x on both the top and the side, your like term should lie in diagonals. Alright, so what we have here now is I still have my f of x equals a times, and what I get when I multiply them is I have an x to the 4th. And let me change colors on that one. Maybe it'll make it easier to see when I do this. Let's go with this. So I have x to the 4th. And then here my like terms lined up. So negative 4x cubed minus 3x cubed is negative 7x cubed. 13x squared plus 12x squared is 25x squared. Minus 4x squared is 21x squared. Let's see. It looks like on this one I forgot my x. So we got what, negative 39x plus 16x. That is negative 23x. And I got my negative 52. Okay, and these numbers are a little different than what I had written down on that other paper. It looks like, looking at it, I made a mistake when I did on the paper that you've got. When I wrote down my Punnett square, I accidentally put the one going across the top is x squared plus 3x minus 4 when it should have been a minus 3x. So I had paused the video, went back through, double checked it, and yes, it's supposed to be a minus, so there's a mistake on the written paper there. But the video should be correct. Alright, so now that we've gotten all those factors multiplied, it's time for us to worry about what A is going to be. Alright, so that's what we're going to use as f of 1 equals negative 120. So we're going to plug negative 120 in for our f of x. And then we got A times, and everywhere we have an x, we're going to plug in that positive 1. So I've got 1 to the 4th minus 7 times 1 cubed plus 21 times 1 squared minus 23 times 1 minus 52. So I'm just going to work through the parentheses there. So 1 to the 4th is 1 minus 7 times 1 cubed is 1 plus 2 times 1 squared is 1 minus, I got 23 times 1 minus 52. I'm still working. I'm just going to do my multiplication now. So 1, bring it down. Negative 7 times 1 is negative 7. 2 times 1 is positive 2. Negative 23 times 1 is negative 23. And we still have our minus 52. So negative 120 equals A times, and I'm going to combine all of them. Okay, I just noticed that this should be right here was a plus 21, but somehow I dropped the 1. So let's add that back in, and let's combine all of those now. Alright, so we should end up with a negative 60. And so we're going to divide both sides by the negative 60. And we find that A is equal to 2. So remember, this is where we're going to take. We know that A is 2. And we also know that up here, right before we plugged it in, so when I take A is 2, and I take that polynomial form there, we have f of x equals, we said A was a 2 times, we have x to the 4th minus 7x cubed plus 21x squared minus 23x minus 52. And we're going to distribute that 2 to it. So we end up with f of x equals 2x to the 4th minus 14x cubed plus 42x squared. Sorry, this is kind of messy. Minus 46x minus 104. And that should be the polynomial that has a degree of 4, which we can see it does. It should have zeros at negative 1, 4, 2 plus 3i, and 2 minus 3i. And it should go through the point 1, negative 20.